Now in this question then, we're asked to solve 4 sine x equals 3 tan x for x greater than or equal to 0 degrees but less than 360 degrees. So how do I do it? Well, first of all, I notice that I have got two different trig functions. I've got sine x and tan x. And what I'd like to have is the same trig function. And I can do that by changing tan x. You should know the identity that tan x is identical to sine x over cos x. So if we just substitute that into our equation, let's see where that takes us. We've got 4 sine x, and then 3 tan x becomes 3 sine x over cos x. Well, that looks like we still haven't achieved anything because we've got different trig functions still. We've got sine x and we've got a cos x. Now what you don't want to do is make the classic mistake of dividing through by sine x. If you do, you're going to be left with this. You're going to be left with 4 equals 3 over cos x. And if you were to take this further by multiplying both sides by cos x, you'd get 4 cos x equals 3. Then no doubt you'd divide by 4 and get cos x equals 3/4. Nothing wrong in that, okay? But what I'll show you is you've just lost a solution. Because what you should do is multiply both sides by cosine x, and so therefore what we get is 4 sine x times cos x equals, and if we times this term here by cos x, you're just going to be left with 3 sine x. As I say, don't cancel out the sine x. What you need to do is bring this term to the left hand side, subtract it from both sides. And if you do that, you're going to have 4 sine x cos x minus 3 sine x equals 0. And then what we do is we factorize. We pull out a common factor, and that common factor is going to be sine x. So if we pull sine x out as a common factor, we're going to have 4 cos x minus 3. Expand this out, you've got this line up here, and this equals 0. Now that means that we have two factors being multiplied together equaling 0, so that means that therefore either sine x, the first factor, equals 0, or the other factor, 4 cos x minus 3, equals 0. Now can you see where this one takes us? Well, if I add 3 to both sides, I get 4 cos x equals 3, and that's what we had here, leading to cos x equals 3/4. So what I've got then is sine x equals 0, or I end up with cos x equals 3/4. So you can see that by dividing through by sine x means you're going to lose out the solutions from this equation. You're only going to end up with the solutions from this equation. So make sure you do not divide out by the sine x. Okay, what I'm going to do is just remove this, okay, just so it gives me a little bit more room should I want to put some more notes in this area. Well, let's start with this equation here, when sine x equals 0. When sine x equals 0, now this is a very common one, okay, you should know the solution straight off. There's no need to draw a quadrant diagram. To get x, x is equal to the inverse sine of 0. But you should really know the graph of sine x. If we took the graph of sine x, it starts at the origin, goes up to 1 at 90, 180 at 0, 270 it's minus 1, and 360 degrees it's 0. So it's 0 at 0, 180 and 360. So our solutions then for x are going to be 0 degrees, the one here, 180 degrees, and you've got to be careful here because although it's 0 at 360 degrees, the range doesn't include 360. It's less than 360, so be careful there, don't write the 360 degrees in. Okay, well we've got two solutions. Now let's talk about cos x equaling 3/4. So what we'll do is just come down on this side now, and so we'll say when cos x equals 3/4, then for something like this I would use the quadrant method. So if we take cos x to be a positive value, 3/4 is positive, then if we draw the quadrants, okay, 0 degrees there, 90, 180, 270, 360. In the usual way, where's cosine positive? We should know it's in the first quadrant and the fourth quadrant. So we can draw a line equally inclined to the horizontal here in the first quadrant and the fourth one, marking those two angles as being exactly the same. Now we want to mark in the possible values of x, so we want to 0 to 360, so it's turning in this direction anti-clockwise. So we turn to the first blue line, that's a possible x. Start again from 0, turn in an anti-clockwise direction to the next blue line, and that's a possible value of x. So to get x then we need to inverse cosine 3/4. And if you do this on your calculator, what you should find that you get is 41.409 and so on. Okay, now that clearly is this red angle here, this acute angle, this little blue one, and that means that this little blue one here is exactly the same, 41.409. So to get the green angle, all I need to do is 360 degrees minus 41.409 and so on. And if you do that, what you find you get is 318.590 and so on degrees. So for these two solutions, we need to round them up to a sensible degree of accuracy. So let's say 1 decimal place, and that's going to give us 41.4 degrees. That's the 1 dp, and the other one would be 318.6 degrees to 1 decimal place. So we have 4 solutions then to our equation. X equals 0, 180, 41.4 and 318.6 degrees. Okay, well I hope you've been able to follow that, and that now brings us to the end of this question.